Hello everybody, how are you? We take before exponential functions. Okay, we take the rules of exponential functions. So here we will take an example. Example said evaluating exponential functions. The first example he gave it to us. A, let f of x equal to the 3 to the power x minus 2. He want me to find f of 4. How can I find f of 4? I said, if he gave me a number between f of, I will put the number instead of the x. So, f of 4 equal to 3 to the power. Instead of x, I will put 4. 3 to the power 4 minus 2. Okay? Instead of x, I put 4. Instead of x, I put 4. So, it's 3 to the power 4 minus 2. So, it's equal 3 to the power 4 minus 2 equal to 2. 3 to the power 2, 3 square equal to 9. This is f of 4 equal to 9. It's that simple, very easy. I will take another example. The next example said, let g of x equal to minus 2 multiplied by x to the power, multiplied by 10 to the power x. Find g of minus 2. So, instead of any x, I will put minus 2. Instead of what? Instead of any x, I will put minus 2. So, g of minus 2 equal to minus 2 multiplied by 10. Instead of the x, I put minus 2. Now, I put it. Now, I will find how much is it. So, it's equal to minus 2. If I want to get rid of minus negative power, if I want to get rid of negative power, I said to you, if I want to get rid of negative power, I move it from numerator to denominator. So it will be minus 2 multiplied by 1 over 10 to the power 2. So I get rid of the negative power. After that, it's equal to minus 2 over minus 2 by 1 minus 2. 1 by 10 square equal to 100. So I get rid of the negative power. I put instead of x minus 2. So the third example I had is let h of x equal to 1 over 9 to the power x. Find h of minus 3 over 2. So I put instead of x minus 3 over 2. So h of minus 3 over 2 equal to 1 over 9 to the power minus 3 over 2. So how can I solve this question? Instead of minus 3 over 2, I can put minus 1.5. It's the same. And if I want to solve 9, if I want to get rid of 1 over 9, I will say 9 to the power minus 1 to the power minus 3 by 2. How I do it like that? I move 9 from denominator to numerator, and I change the exponents, the power, from positive to negative. So I had 9 to the power minus 1 also to the power minus 3 over 2. So if I had two powers to the same base, I can multiply them. So 9, it will be 9 to the power minus 1 by minus 3 over 2, 9 to the power 3 over 2. So the basic shape of 3 over 2, 3 is power, 2 is root. So it's equal to what? 9 and under a squared also to the power 3. 9 under squared to the power 3. So 9 underscored equal to what? Equal to 3. All of it to the power 3 equal to what? 27. So it's that easy. The most important step I do it, I move 9 from denominator to numerator to get rid of 1 over 9. So I will set 9 to the power minus 1 to the power minus 3 over 2. And I gave you a rule that said if the base had 2 exponents, I can multiply them. So minus 1 multiplied by 3 over 2 equal to 3 over 2. So the 3 over 2, the denominator is a root, the numerator is a power. So what I do, I put it in the basic shape. I put 9 underscored because the root equal to 2, and I put it to the power 3 because the power equal to 3. So 9 underscored equal to 3 to the power 3. 3 to the power 3 equal to 27. So this is the third question. The fourth question is, let f of x equal to 4 to the power x. Find f of 0. So instead of any x, I put 0. So I will solve it for you. I said f to the power 0 equal to 4. Instead of x, I said I put 0. I gave you a rule. The rule said any number, any constant, any variable had power equal to 0, it's equal to 1. This is a rule. You have to save it in your mind. Don't forget it, please. I will write it for you. Any constant or variable had a root or had a power or an exponent equal to 0, the result will be 1. Equal to 1. Number 1. Please don't forget this note. It's very important. So any number, any variable, any constant had a had a power equal to 0, the result equal to 1 always. So I complete these questions. So here we take rules of exponents. I take it before, I give it to you before. I only want you to remember these rules because this rules is very important in our subjects. So rules of exponents said a to the power x multiplied by a to the power y. This means the same base but in difference with different power. So if I have two bases, the same bases but different powers between them, there is multiplied. So I take the same base and said take the sum of the two powers. So I take x plus y, but the bases have to be equal. The bases have to be the same. So the second rule said if I had a base to the power over the same base to another power, I take the difference between them. Here I take the sum between them. So if I have bases, the same bases multiplied by each other, but the powers are different, I take the sum of the two powers to the same base. If I have two bases over the first base over the second base and is the same base but the power are different, I take the same base and they take the difference between the two bases. So the third rule said if I have a base multiplied by another base but all of them to the power, to any power, so I will distribute the power to the two bases, like a by b to the power x, all of them to the power x. I distribute x, the power x, over a and b, so it will be a to the power x by b to the power x. The fourth rule said if I have a base with two powers, like a to the power x and to the power y, a to the power x and to the power y, it will be equal to a to the power x by y. So if a base had two powers, I will multiply the two powers. Here I will multiply the two powers. I gave you this rule. Any number, any variable, any constant with power 0, it's equal to 1, always equal to 1. The fifth rule said if I have a base with a negative power and I said I don't accept a negative power, what I had to do, I will put it in the, if it was in the numerator, I will put it in the denominator and get rid of the negative. If it in the denominator like this, if it in the denominator a to the power minus x, I want to get rid of the minus, I said a to the power x. I move it from denominator to numerator. Okay, this is very simple rules. I gave it to you before, so I will give you an examples for these rules, like 6 to the power 2 multiplied to the power second power 3. So I said if base had two powers, I take the multiplied of the power. So 6 to the power 2 multiplied by 3, 6 to the power 2 multiplied by 3, 6. Okay, put it like this shape, there is no problem. And another example said 2 to the power 3 multiplied by 2 to the power 1. So I said if I have the same bases between them multiplied, I take the sum of the power. So I take 2 to the power 3 plus 1 equal to 2 to the power 4, equal to 2 to the power 4. So another example, I will give it to you. 3 to the power 3 over 3 to the power 1. So I said if I had two bases, 1 over the second, I take the difference of the two powers. So 3, the numerator minus the denominator. The opposite isn't right. The numerator minus the denominator. 3 to the power 3 minus 1 equal to 3 to the power 2 equal to 9, or put it like this shape, I don't have any problem. So another example for another rule said 2 multiplied by 3 to the power x. So I said if I had two different bases with a power, I will distribute the power to the bases. So 2 to the power x by 3 to the power x. Now this is very simple rules. You take it before 1, 2, 3 more times for these rules. I will give you a homework to know how to solve like these rules. So I gave you this homework to solve it. Try to solve it in your home. Try to think about it. It's very easy. I gave you two bases multiply by themselves, and there is bases in the numerator and there is bases in denominator. Between them multiplied, between them divided. So what can you do in this homework? What can you do in this homework? Simplify this question. So try to solve it in your home. Please let me know if you solve it or not by our groups in Telegram. Thank you very much.